Globally, energy costs continue to increase and fluctuate unpredictably, while the impact on the environment from energy production and use remains a concern.
Well, these challenges in our global inefficient use of energy resources prompted us to look at low-cost, abundant waste materials to see what energy was available and how we might convert it to use.
So here in our lab, we began to look at concentrations of acylglycerols and free fatty acids in a variety of waste streams, including municipal wastewater streams and food processing streams. The challenges were significant in finding new chemical processes that allowed us to extract usable energy from these highly mixed wastes.
Their combined efforts during the past decade at Idaho National Laboratory produced a chemistry breakthrough called Supercritical Solid Catalyst, or SSC. Bob Fox, working in supercritical fluids, and Dan Genesar, researching catalytic reactions, created patented inventions that produce high-quality B-100 biodiesel from a variety of wastes. SSC mixes fat or oil feedstock with supercritical fluid solvents and alcohols at specific temperatures and pressures to completely dissolve the materials during a single supercritical phase. This approach overcomes the polar liquid phase in conventional biodiesel production, replacing the multi-step approach. Biofuelbox Incorporated of California scaled SSC to demonstrate it as an efficient, commercial capability and industrial process.
INL's supercritical solid catalyst broke key barriers for Biofuelbox. It enabled cost-efficient, localized waste-to-energy production for municipal, for industrial, and agricultural partners.
Conventional biodiesel production requires high-quality oil sources, such as soybean oil or other food crops. SSC takes the worst wastes and revolutionizes production of high-quality B-100 biodiesel fuels using a single step. Benefits include delivering a fuel that has 86% lower greenhouse gas emissions than petroleum, offering a secure domestic fuel source, eliminating the transportation and use of toxic materials, eliminating large amounts of clean water consumption during biodiesel production, avoiding disposal costs and carbon dioxide methane emissions by diverting 10 million pounds of waste from landfills per plant each year, and potentially replacing 20% of petroleum diesel in the U.S., representing crude imports of 800,000 barrels per day. Disruptive technologies often forge the future. The World Economic Forum in Switzerland selected the Biofuelbox demonstration as a disruptive technology pioneer, developing groundbreaking products and services that can help achieve the promises of sustainable energy. Supercritical Solid Catalyst and the Biofuelbox demonstration move energy production in a new direction toward efficiency. Once liabilities incurring costs for disposal, these wastes are now assets. They are new energy resources, offering an attractive, environmentally friendly step toward energy security for the future.